Okay, so now let's get into some programming. The application, very, very popular application out there that many have, it's part of many teaching coursework. Introduction is this iris data set, which is 100 pictures, no, not pictures, but measurements of 150 flowers. Each of these flowers are one type of iris. There's three kinds. There's the versicolor, setosa, and virginica. So what we're going to do is train the neural network to not neural network, but a machine learning algorithm to tell between these different algorithms between the different flowers by measurements of that flower. So what measurements are we going to take? Okay, I'll get to that in a second. All right, so the way we're going to do this, we're going to do a basic pipeline, data science pipeline. Data science, working from the data through to results, some predictions. And here are the steps. First, getting Python. We're going to use the SciPy platform. So that's the preparing your environment. Then your program, your Python program is 1 through 6. So first you load the libraries, you load the data set, the iris data set of numbers associated with this. See in a second. We'll then summarize the data set, take a look at what it's like. We'll then visualize it. We'll do some graphing, see what the data set looks like. Then we will see how well different algorithms work on the data set, different machine learning algorithms. And tonight, I'm not going to teach you all the different algorithms. What I'm going to do is just give you a taste of how they work. And we will be going into them in depth in later classes. And then once we've decided, okay, which ones are the best, we will make some predictions from them and see indeed which ones, that one is actually better than the other. We could tell which ones were before that from the results of training the algorithms, but then we'll actually see that they are. And then we'll talk about further study, which will be part of the homework assignment. So that's what we're going to do in the next 45 minutes. All right, so the beginning. All right, at this point, you need to type all this in. No, I'm kidding. What I'm going to do, I'm going to jump ahead and, let's see how to do this. Maybe what I should do is pop this stuff, each one of these. And there's two things we can do. There's the easy way, okay, which is probably the least effective way, is that you go to my GitHub and you pull down the program. But what I'd rather you do is actually pull this code step by step into your program. And if you are using Jupyter Notebook, then that's really the way we want to go. So first of all, let me just go ahead and give you the GitHub so that you can go this route if you want. Let's see, can I do this? Copy link address, and I'll post it in the chat. Okay. I think that works. Let's click on it, make sure it works. Okay, yes, it works. All right, so those that are familiar with GitHub, you know how to do this. So once you're, okay, hold on, I got a possible question. Okay, here we go, thank you. Thank you, Anvesh. All right, so you go here, go into lecture 3, and then you'll see here this IPYNB. Actually, what you got to do is just download the whole thing. So let's go back. Give me 1 second here. Kind of. Okay, clone or download. And you can download the zip if you want. And then from within the zip, lecture 3. So here's the notebook file. So if you put this into a specific place on your hard drive, and then navigate to it from within notebook, then you'll be able to get there. So if just to go straight there, here I'm there on my notebook on my computer. So I guess raise your hand if you are lost, if you want me to slow down, just kind of give me an idea. If you need a minute or if you're stuck, if you have a question. So I always found that when I was in classes learning stuff like this, I really wanted to follow along. Okay, got a question here. How do you open it in Jupyter? Okay, you got to get Jupyter started, which the way you do that, and I can go ahead and restart mine to show you on the command line. Okay, sklearn. Okay, got 2 questions here. So let's start with the first one. Let's get Jupyter started. I'm going to go ahead and do Control C so I can stop my Jupyter. And if you have it installed, which pip install Jupyter, then let's just do that. Pip install Jupyter. Okay. Then you just run Jupyter Notebook. Okay, one thing at a time. Okay, so Jupyter Notebook. And then that will automatically open up a a tab in Chrome or whatever your browser is. My computer can be very slow at times, but okay. While that's running, let me look at some of the other questions. Okay, so sklearn on Python 3 is not working. on it, Python 2, it is working in Jupyter Notebook of Anaconda. I don't know the answer to that. I've not run into that. Python 3, we got to do Python 3 here. This is written for Python 3. There's minor changes we could do for Python 2, but we have to get sklearn going. I know you were having a problem earlier, Shafiq, so we'll look at that. Okay, what if we have Anaconda? Well, if you have Anaconda, all of this I think should be already loaded, so should not be a problem. Okay, there's open Jupyter Notebook from Anaconda. Then you upload the file. Okay, that's I don't use Anaconda, so yeah, we're going through a demo on using Jupyter right now. I just showed how to open it, how to install it, and then how to open it. Let's see. Okay, yeah, it looks like Giganda is helping with this a little bit with Anaconda. Sorry, I'm just not, I'm not an Anaconda user. I've always just installed straight from Python, straight Python, and then inside of the libraries after that. Okay, okay, to see the button in GitHub, that's an easy one because if you just go to the link under lectures, then you should see the clone or download. If you actually go into lecture 3, go into the folder underneath it, then you will not see the download. Hopefully that helps. That baffled me for a while too. Let's see, what else? Okay, hopefully that answers all the questions to the best of my ability without looking at your computer or understanding Anaconda. I mean, you can, even if you have or using Anaconda, you can still open Jupyter from a terminal session. Let's see. Okay, hopefully that gets everybody going. Okay. Okay, so let's go. Let's open the data set. Hopefully the rest of you are good to go here. If you're still having problems, we can talk about this, one-on-one. I'll take note of who had issues here, and I'll follow up. But you can just follow along, in here. Okay, so let's say you have this open. Can I send a file to you? Well, I shared the GitHub, so that should be enough. Then you can download it. Okay, so first step is load the libraries. Okay, and so what libraries are we using here? This is also something I'm going to gloss over somewhat because I mean now we've got 30 minutes. That is what libraries we're using here. Okay, pandas. We are going to go more into this. This is the section on computing for machine learning, or computing for statistical learning. Is talking about these different libraries. So pandas is the library for data, pulling in data is the biggest thing. But it has other stuff in it. But we'll talk about that. So so plotting, we're going to do a scatter matrix. That's part of pandas. Plotlib is all we're going to do a plot that comes from there also, pyplot. different types of graphs we can do. sklearn is scikit-learn that is got all of our machine learning algorithms in it. And as you can see, it also has metrics, ways we can measure our machine learning algorithms. And you can see the models we're going to load are logistic regression, decision tree classifier, random forest classifier, k-nearest neighbors classifier, LDA or linear discriminant analysis, the Gaussian naive Bayes, and the SVC classifier. These are all very popular machine learning algorithms, and we're going to try all of them. All of these. There's many more. I can think of 3 or 4 right off the top of my head more, but these are very popular ones. A couple of newer ones are very, very powerful. Everybody uses them, and I don't even have them here. Random forest is very popular, but well, there's some that are more used than that are really just variants on that. So XGBoost is one of those. Okay, so to run this, you just either click on the run button, or I did the shift enter. That's my shortcut. And since I haven't done any Python here, I only have 8 gig of memory, so it's gonna sit here for a minute, first time, and get my memory set back again, pull it from other applications back into this one, out of the cache, out of the trash, I mean cache. Sorry. Okay, so while that's running, go back to slides and back up to beginning here. Okay, import the libraries. Okay, see how many algorithms there are, or how big the library is. Love that picture. Okay, so the next thing we do is pull in the data, because we can't do anything till we have the data. Okay, so what kind of data do we have here? Well, first of all, let's just go down this. Okay, this data is out there on the website, on the internet, and to pull in something off the internet into Python is actually quite simple. This is how you'd pull it in if it was a comma-separated variable text file, which is going to be your go-to method for pulling in data. There's other ways. You can actually pull it in direct with SQL. You can scrape the web. We will do some of that. That's cool stuff, and I highly recommend doing that for our project. Is find out where this stuff is on the internet and scrape it off of there. We will do that. Do some JSON, or however the good ways of doing that. This data in the CSV does not have headings, so we're going to give it headings with its names. It's got sepal length, sepal width, petal length, petal width, and also then our answer, which our classification of flower, which is the last column. If you look at this picture over here on the right, gives you an idea of what a sepal is and what a petal is of a flower in general, in specific the iris. And we have different measurements. We have the length and the width of each of those for bunch of flowers of 3 types. So, okay, so if you look here, I got my code up at the top. Okay, and then when I run the code, it gives me this output down at the bottom. So let's just go do that real quick so you can see it happen. Okay, this is going to be difficult. So what I'm going to do, separate this to a different window. And so I can go back and forth between my lecture and running the code. Okay, so that finally finished. And now we'll go to the next line and then run this one. All right, that went quick because now I've got libraries loaded. I've got the memory grabbed. So, okay, so I pulled in the data. Oh, actually, this is how I pulled in the data. I set a variable URL to where it is on the internet and then pulled it in and set the column names. That's what this command does. It uses a pandas command, read CSV. And we have a variable now, data set, that's set to all of it. All right, that data set has a shape, and we're going to print that. And this is what we see. It has 150 rows and 5 columns. So here are the 5 columns. And I'm only showing the first 5. I can get to that in a second, but that's what our data set has in it. Okay, so that's the shape of the data that came in. Then I'm going to print the first few records of it. So this is what I see when I run that command. First 5 records. And this first column is just a number that's assigned, starting with 0, to each line in that in that data set. Data frame is what it actually is. Okay, so then I then print. I run a nice little command here for a group by. If you know any SQL, then you know what this does. I'm going to count each by class, this last column, how many rows there are in each one of these. And I end up with 50 for each row, which is fascinating. Okay, so is there another chat? A question. Okay, so that's my first bunch of code. I'm basically loading the data and showing what's there. You know, doing a quick look. Okay, this is a very simple data set. In the future, if our data set's more complicated, we will probably want to do more. But this is a quick, rough count. You know, make sure our data is complete. Okay, so next thing we want to do is a general rule of thumb. Excuse me, is do some statistical evaluation of these numeric columns. Notice it only did it on the numeric columns. So what this does, I ran this dataset.describe and did a print to get it onto the screen. So I printed statistical description of data colon line break, and then the dataset.describe, which is the rest of this. So each column prints out 8 numbers, each numeric column. How many there are? Non-zero or non-null. Sometimes you're missing data, and we will definitely go into that because that's very common in the real world. We get a mean of each one of these. We get a standard deviation, minimum, maximum, min, max, and then you get these different, like a mode. You know, at 50%, half of your data is bigger than this, half of your data is smaller than this, 25% is smaller than this, the rest of it's bigger. 75% smaller than this number, 25% is bigger. So it gives us an idea of what our data looks like overall. Okay, so let's go back to our code and run that part. So we ran this one. So move to the next one and run this one. Okay, so we ran that statistical data. Look at the statistics. So now we're gonna do the next one, which is already showing here, doing some plotting. Okay, so now we're done with the numerics. Let's visualize our data. So important. As you know, a picture's worth 1,000 words. So we're going to do a lot of this, and I'm going to want you to do more than just what I'm showing here. It's kind of get an idea of what does your data look like visually. And these box and whisker plots are a great way of showing this information. If you look, the sepal length, the first little graph here, got a green line in the middle, which is our mode. We've got a number up here, which is our, I think that's our 75% number. A number down here is our 25% number. And then we have our minimum and maximum. So most of our data is in this box. We got the outliers, we got stuff out on the outside. Now this one's a little different. Somehow they decide whether to include the outliers in the minimum and maximum. For whatever it's worth, it's what they do. For this, make it a little more interesting. Maybe it's like a 2% rather than 25%, like a 2% maximum or minimum, and then you have a couple of numbers outside that. Okay, we got a question here. If we have null in the class, does that also get showed with the group by and pandas? Usually you would get rid of those nulls first. That's one of the first things you do before you really start looking at your data. Yeah, well, let's go back. Yes, because that's just telling you how many records there are in that class. How many records have Iris setosa as that? It doesn't matter what those are. Oh, I'm sorry, if you have nulls in that class. That's a good question. I can go back and look at that. The problem with a record like that and is how are you going to use that record? How are you going to train something on that? I mean, you might say how many, or you might try to predict whether you're going to get a null or not as one of the classes, but then you would set that to a class. So probably the answer is yes, but I will go back and look at that. Good question. All right, so here's another view of the data. It's histograms. So we're looking at now, okay, how many of each of these measurements are there? And as you can see here, for sepal length, there's a whole bunch of really small ones. And then you kind of have more of a normal distribution, regular distribution here. And same with sepal width. So maybe that means that a lot of these flowers have very, very small sepals. And we had a problem measuring them. Or they were missing, something like that. So that's going to tell you maybe, what kind of flower that is. So that would be a nice piece of information that we would be able to glean from this. Okay, so we have nicer normal distribution for these measurements. All right, so this down here. It's just annoying to make it go away. All right, so these are other measurements, or other graphs we could look at, and these you almost always do. These are similar to a correlation matrix, a heat map. So what we did was take all of these measurements and put them up against each other and do scatter plots. So let's take, for instance, this upper right-hand corner one. Along the base is the petal width, and along the vertical is the sepal length for each one of these flowers. So as you can see, the larger the petal width, also the wider the sepal length is. You're going up. Generally, we kind of have a nice linear relationship here, and we have this group for really small ones down the bottom. And actually, I just figured out why this is, why you have these small ones. And there's one type of flower that is kind of grouped down there, because I mean, if we go back and look at our flowers, you can see that this one's much smaller generally than the other ones, at least the way they drew it, they took the picture. So, so that's kind of why you have those groupings. And we're going to see that. Well, actually, we don't see that in this this run. Okay, so but we can look at that. Maybe next time we'll look at that. So you see a lot of linear relationships. It's just very interesting information you're getting by taking a look at this. Your relationships between all your values, which makes general sense. The bigger your flower, the wider it is and the longer it is. Okay, so now we're ready to start modeling. We've taken a look at our data. We've gotten an idea of what it's like. We see relationships. Now we're going to see if we can use a system to pull that information out. So what we do is we split our data set into different parts. We have your independent variables and your dependent variables. That's the first thing we do. So we set X to our inputs, which is how you set it to the first 4 columns of our data. And then we set Y to the last column, the 4th column, which is actually the 5th column. That's how you count in Python. You start with 0. And then that's one way to split our data between input and output. Then what we were going to do is split our data between training and test. Train and validation is the terminology they use here. And we will talk much more about that in the future, between test, validation. They're similar, they sound similar, but we use them differently. And I don't want to get into that now. So this is a command we use for generating data for models for testing, for training and testing. And this train test split is the command. And what we do is we feed in the X, we feed in the Y, we feed in the what percentage we want for test. We want 20% to be held out for validation. And then we would do a randomizer. And so that we get the same results every time, we're going to set that seed to a number. We can set it to any number. So, and if you set it to the same number, you're going to get the same results that I get. And we'll get the same results every time. So that's just some code we got to run. Okay, the next thing we do is string together all of our models into an array, into this array called models. this is just instantiate them. This is not actually doing anything, but creating a place in memory for them. And it's a two column array. First column is a abbreviation for the model type, and second column is the actual model itself. So we're setting up an array of models here. Okay, and then we're going to actually do some training. And we're going to use the cross-validation, k-fold cross-validation, which we will go into that. I just want to demonstrate it here. So what we're setting up two arrays for results and then names. Names are our abbreviation. Results are how accurate we are. So then we're going to do a loop through our data. I'm sorry, through our models. And for each model, we're going to set up a k-fold cross-validation and splits of 10, which we will go into that. Don't worry about it right now. It's just a way of us coming up with the most accurate model within, as quickly as we can. So then we're going to score our model. We're going to run the model, fit the model, score it. That's what this does. It's not intuitive that this is actually doing the training, the fit, the training on the data, but it's what it's doing. Then we've got results coming out of this. Yeah, the answer that we're getting out of it is results, and that's just a number. Closer to 1, the better the algorithm did, which we'll see that down here. So results, we're creating that array. We're creating the names. Adding the names as another column. Creating another array. Then we're going, as we're looping through this, we're then going to print out the results. So we're going to put print name, then the average of the results, and then the standard deviation of the results. And that's what we're getting down here when we actually run it. Basically what we see here is the logistic regression or linear regression gave us a result of 0.96. So 97% of the time it was correct. The LDA gave us 98%. KNN gave us 98%. The CART that gave us 97%. Random Forest gave us 96%. Naive Bayes gave us 98%, and SVM gave us 99%. Look at that. It's almost 100%. So if we look at this, KNN and SVM gave us the best results. So note. Okay, so now if we can plot these results. So going across the bottom is the algorithm, and then we're doing a box and whiskers. So the lowest result we got was 92%. It's same here. We got an outlier of 92%, but most of them were up very high for this one. I believe this is the KNN. So that's how this works for different algorithms and what the results are. So now, okay, we've got which ones are the best. So now let's go and actually do some prediction. This is what you usually go straight to and then evaluate based on this, but it's kind of a nice quick quickie way of determining which is the best, doing that for that loop, that for loop, and the cross validation. So if you look here, this is more of the standard, the way you're going to see the process of training on your data. Okay, it's much more straightforward. Okay, we're going to take our training data. Okay. First of all, we're going to instantiate our classifier. Okay, we did this before, but we're just kind of starting from scratch here because we're going to take our best models and compare them. That's the goal at this point. So we're instantiating the we're creating a k-nearest neighbor classifier. Then we're going to take that and fit it to our training data, the X train and Y train. This is our data split. It's 80% of our data split between the first 4 columns and the last column. And this fit method function does all the magic. It goes behind the scenes and actually trains, which is not incredibly intuitive. And we will look at the theory behind each one of these models in the future. In a future class, we're going to pull apart each one at a time and look at what happens behind the scenes when we fit on data. See how it does it. So give you an idea of why do we use that particular model? Why is another one better than this? Why is this one better than another one? All of that will become extremely transparent when we go to actually learn what the KNN, the k-nearest neighbors model does. And then what we do is we predict on the validation data. What we do is we end up with a bunch of Y data. The Y underscore validation is going to compare to what we predict when we plug in that last 20% of those 4 columns, the validation data. Then we're going to print the accuracy score. How accurate were we? And we're going to base that on the Y validation, which is when we split the data, this is our actual correct data, and it's our predictions, which we just came up with. We're going to come up with a score, which here you can see came up with 0.9. Then we're going to do what's called a confusion matrix between our validation and predictions. So what the confusion matrix gives us is an idea of how many we got right. Remember, we split our data 20% validation, 80% training. So 20% of our total data, we had 150 records. 20% of that is 30 records. So each one of those was either right or wrong. This confusion matrix tells us how many were right and wrong. So this down the middle is the ones we got right, is the ones that we said we predicted that it was Iris setosa. It actually wasn't Iris setosa. We have 3 classifications, so that's how many are there. This middle one is how many were Iris versicolor, and how accurate were we there. And then this one is how accurate were we with the last one, the Iris virginica. If it's off the middle, then that means we were wrong. We predicted one and got another, and I forget which one is which. But yeah, so as you can see, we missed on 3, but we got 27 right, the rest of them. That's why we got 0.9. So this confusion matrix is very powerful. Good way of viewing the information. Then we have some statistical information that is related to that, related to our guesses, our predictions. And that's the precision recall, F1 score, and then support. So we will go into that later. That's very interesting. It's stuff you just have to know in order to know how well your algorithm worked. Okay. Okay, now then just real quick, same exact thing for the one that we actually got the best results on, the support vector machine, support vector classifier, which gave us a 9.93 accuracy. As you can see, it missed on on two instead of three. So that's why it's more accurate. So there you have it. Those were our best. Okay, so homework. Okay, lecture 1, lecture 2, I'm just kind of showing that again here. Make sure you get on the Slack channel. You know, we got all kinds of questions flying around. You know, I'm using that to evaluate, you know, a kind of a contest, you know, you know, who's kind of part of that group, you know, who's asking the most questions, who's doing the most. And let's see, my winner, I said, you know, last time who's going to be, that I was going to pick a winner. And Mo Sun is my winner. He interacted the most on Slack, between specifically with me and also with everybody else. So congratulations, Mo Sun. You know, you've won the first week, so very good. Also, Shafiq came in second. He's actually local out here, so it's awesome. So anyway, so moving on. Okay, so what's your homework for next week? And we are going to talk about this in depth. I mean, next week. Well, no, I'm basically going to announce this during class next week and put a lot of stuff together as a result of this. What I want you guys to do is take what I did here, get it working, and improve on it. Okay. Now, what does that mean to improve on it? Try out different algorithms. See if you can get a better result. You may not be able to. It's a pretty small data set. Another way to improve on it is to show more graphics, more visualizations, more statistics. You know, do more testing. I have a whole list of ways that you can improve on it, and it's basically in my the README on here. Things you can do. So let's look at that. It's on here. Escape. So if we go up, oh, I don't. Oh, this is on my machine. It's out on GitHub. I haven't synced it up yet. So if you look out here, if you go to lecture 3, the README on this, I have things that you can do to improve on it. Add XGBoost, like GVM, other algorithms, anything that you can find out there. Apply a neural network to this. That will be incredible. That would be nice. You can use can use Keras if you want, make it simple. Next week, we're going to go through actually developing a neural network from scratch, not using Keras or TensorFlow or sklearn. You know, we're going to scikit-learn. We're going to do all the calculations so we can understand that, and then we're going to do that also with a few of the basic machine learning algorithms, not the more complicated ones, but you will understand them. You can do, you know, try other feature engineering, like take length over width, feed that in, see if that improves it. See if you can just do it with length over width, what kind of accuracy you get. Let's see, what else? I want you to, okay, if you can tell me how much each feature contributed to our answer. That's extremely important thing. Should be on here. Also, some unsupervised classification. See if you can determine what types of flowers there are, how many types there are, without looking at the actual answer, without the classes. So those are some things. Oh, probably the biggest one, sorry, is the first one there, is adjust the hyperparameters of those models. You need to Google the models and take a look at how you can adjust them. I mean, I did them default parameters. There's half a dozen on some of them of different parameters you can adjust to maybe get them to be more accurate. So that's our homework. See, let's got some questions here. How to handle if any of the measurements are 0, which does not make sense. You can treat those like nulls and do some replacement. You can drop the whole record. You can basically replace it with an average, something like that. There's a lot of different things you can do there, but you want to test each one of the things that you try and see if it makes a change. Can we achieve the same accuracy as we saw in cross-validation while fitting the individual model? Yes, basically you would fit it with cross-validation. Cross-validation is just a way of averaging a bunch of models all together. Splitting up your training and test set differently and then averaging them. That's what cross-validation basically is. So yes, but you would have to do cross-validation to get that same accuracy. Why does SVN have the highest accuracy? Probably it has the most nonlinearity in it, in the base form. My guess is if you do some hyperparameter, if you change the hyperparameters, if you tune the other models, you're going to end up with as good, especially the random forest, because that ends up being many, many times the best. Is it in GitHub? Yes. I'm not sure what it is. Maybe Anvesh, you could specify more specifically. Clustering, yes. When I say unsupervised classification, yes, clustering. Whether it's the K nearest neighbor clustering, K-means clustering, yes. Does performance change if validation set is decreased? Perfect thing to try. Does it? It should become more accurate, but it depends on what part of the validation set it is. You know, it's random. So if you're doing the cross-validation, then no, because you want the best, and you don't want to overfit your model, which we didn't talk about that tonight, but we will. And yes, that is something useful, definitely. Changing that around depends on how many outliers you have. I've seen OpenCV project where there's 300 images to learn features on, and the model kept only a few images to validate with. Okay, yeah. I thought you were going to go toward use images of the flowers. You know, that's one way you could increase your data set. Use the images, but that's not what really we want to do here. But yes, it just depends. I mean, it depends on how distributed your data is and how much you're going to overtrain it. That's really what you're playing with at that point. So, okay. Oh, when you were searching for improvements on local notebook, I was saying, okay. Thanks, Anvesh. What about increase sample size by creating art? Increasing the sample size. So increasing the amount of data by adding jitter, stuff like that, perhaps. Creating new features. I guess that might be what you're saying. I don't know if you're saying more data when you say sample size or more columns. You know, by doing some unsupervised classification. You add another column that's you know, you broke apart your data by you know, an unsupervised manner, and add that as a column. Using Boltzmann machines, doing more data. I have to get back to you on that one. I'm not exactly sure, but there's adding jitter to your data. Basically, just kind of taking your data, randomizing it a little bit, and creating more data. So you can do that. But I will get back to you about the Boltzmann machines. So other than that, that's pretty much all I wanted to go through tonight. Trying to think if any other questions. I'm going to hang out for about 10 minutes and see if there's any other comments, any other questions. Anybody needs help getting their environment running. If it's involving Anaconda, I might have to wait till tomorrow, but where can we submit the homework task? Very good question. GitHub. I mean, just basically put it up on GitHub, and then I'll take a look at it there. And I'll put something out there that I'll let you guys know how to submit it. Definitely by Monday, how you would get it to me. But right off the bat, just GitHub. As you can see on my GitHub, I created a class folder. Let me just pull that up here. Or lectures, I should say, lectures folder. Deep learning, deeper side of learning. A bunch of stuff out here. Some that's not that exciting. I create a folder called lectures, and then with that, I created lecture 3. If you model that, then you're golden. You can also put data out here if you want. Otherwise, pull it off the web. But yeah, and explain what you did in the README. What you did extra. That's probably the best. And then I can check it out there. The due date, I want to say next Wednesday, because what I want, everything that's done by next Wednesday, I'm going to talk about on Thursday. I want to go through it all. I want to show everybody, what are some of these things, and I'm going to do some of them myself. And one other thing, getting information, copying other people's information. I hope that you don't do that. There's lots of answers on IRIS dataset. So let's not do that. Let's try to come up with ideas yourself. At least if you do get ideas from others, just at least create the programs yourself, right? Write it up yourself. So that's it for now. Just answer questions. I'm going to go off video and just stay around for answer questions.